In this video, we're just going to talk about how you can use sine, cos, and tan to get the length of a side in a triangle that you have not been given when you've been given another side and an angle, or how you can get the measure of an angle in a triangle when you've been given two sides within the triangle. This right here that we've got the diagram in the middle is just a quick recap of the trigonometric ratios and how we will use them to relate them to each other. So for example, we can see that the sine of theta is the opposite over hypotenuse, which means that theta itself is going to be sine inverse of opposite over hypotenuse. Similarly, cos theta is adjacent over hypotenuse, so theta is equal to the cos inverse of adjacent over hypotenuse. And tan theta is equal to opposite over adjacent, so theta is equal to tan inverse of opposite over adjacent. So for each of the questions that you're given for this, you just need to know which of the ratios you need to choose and then work from there. Let's look at a couple of examples of this. So with these two here, we have to calculate to the nearest degree the angle marked with a letter. So in the first one, we've got our angle theta, and we've been given the length of the side that is opposite to it and the side that is adjacent to it. Now the trigonometric ratio that uses opposite and adjacent is tan, which means that the tan of theta is equal to opposite over adjacent, which is 3/2, which means theta is equal to tan inverse of 3/2, which means that theta is equal to 56.30993247, but we're going to get that to the nearest degree, so theta is approximately equal to 56 degrees for this. Okay, now for the next one here, we've got our angle theta, and this time we've been given the side opposite it and the hypotenuse. The ratio that uses opposite and hypotenuse is sine. So in this case, we have sine theta is equal to 12 over 17, which means that theta itself is going to be equal to sine inverse of 12 over 17. So theta is equal to 44.90087216. But we're looking for this to the nearest degree, so we're going to round that to approximately 45 degrees, like that. So that's how we get the measure of an angle when we've been given two sides in a right angle triangle. Now let's take a look at how we get the missing side when we've been given an angle on one other side. So in this first case here, we've got an angle of 28 degrees, the opposite side is marked A, and the hypotenuse is marked 20. The ratio that uses opposite and hypotenuse is sine. So the sine of 28 degrees is equal to A over 20. And now we just need to do a little bit of algebra to rearrange this so that we can get to a point where we can get a value for A. Well, if we bring this divide by 20 over, it becomes multiply by 20. So we get 20 times the sine of 28 is equal to A, which means that A is equal to 9.38943126. And we want that correct to two decimal places. So A is approximately equal to 9.39 in this case. Let's take a look at another example where we've got a right angle triangle. We've got an angle marked 34.5. We've got a side marked B and the hypotenuse marked 35. The trigonometric ratio that uses the adjacent, which is what we have, and the hypotenuse is cos. So we're going to say that the cos of 34.5 is equal to B over 35, which means that 35 times the cos of 34.5 is equal to B. So B is going to be equal to 28.8444166. 28.8444166. And we want that to 2 decimal places. So B is approximately equal to 28.84. And that is how you would use trigonometry to get the length of a missing side in a right angle triangle, or the measure of an angle when given two other sides in a right angle triangle.